basically, what we're going to do today is build a very simple application, which is going to use a real-time messages from a chat, and we're going to try to deploy an ML model to analyze the sentiment of the messages in real time. And we're going to do it a bit differently that maybe other type of architecture would do. We're going to use Python, Kafka, and Kubernetes together to create a stream processing pipeline and deploy this ML model on the edge and get a feedback to the application with no delay. So we are here introducing different concepts, new concepts. So to data problems. One of them is microservices. So that's quite familiar in software engineering, but not that much in data engineering. So rather than sending data to database and then reading them from database for batch processing, we actually introducing microservices that are being deployed in a pub and sub manner. What that means is that we're subscribing from data coming from your chat and analyzing in memory the data and then publishing results back to the broker. We're going to use Kafka as a broker. That's going to give us reliability and efficiency for doing that. And we're not going to use SQL but Python. So everything we do today is built in Python, and so hopefully it's friendly for data scientists, data engineers, and etc. So if we go to the next slide, Javi, can you talk about difference between streaming and batch and why the streaming is important for today's presentation?
Sure. So as Thomas had just said, streaming is at the core of Wix. And for those of you who don't know much about streaming, we have this very short high-level presentation, high-level slide telling you what it is about. And the classical way to present streaming is as opposed to batch, to the more traditional batch. So let's think of a data flowing system as that river that you see over there. Under the batch processing approach, you collect a set of information over time. So you fill that bucket. And once that's full, you load it into your system for processing. So again, you collect a batch of information and then you send it for processing. Under the processing approach, what we do is we collect the data piece by piece, so we are able to process it and react to it piece by piece. And that means we do it pretty much in real time. Check that loading plus aggregation operation that you see over there. You can see how with the streaming, we can save a whole step. So this has implications in speed, in computational resources. You see how batch processing may work well, but only in situations where you don't actually benefit from real-time analytic results. And dealing with big batches of data is not too costly, computationally speaking. So with that little presentation done, we're going to start building an application that is going to read your messages and perform sentiment analysis on it. One of the main elements of any streaming applications is topics. So the first thing that Thomas is going to show you is how we connect a web app to a topic so that every message that you send go to that topic, and how we create a service in Wix that reacts to those messages in any way we want. For instance, performing sentiment analysis on them. So Thomas, do you want to start the dangerous demo?
Yes. So can you stop sharing so I can share my screen? Cool. So I will share my browser. Please let me know if you can see it.
Yes, we can see it.
Cool. So here in my workspace, I have this simple front-end application that gonna be our producer and consumer of data today. I'm going to enter room demo as a Thomas. And optionally, I can add my phone number because we're going to do some stuff with Twilio later, but it's not that important for now. So here, if you can please take your phone and scan this QR code to join me in the chat. So you can send me some message that you are in. I'm going to wait some time to give you the opportunity to fill your name and join me here. Cool. So we have Sean, KK, Chris. Amazing. So this is working. What this is doing actually? Well, this is using a WebSocket gateway between the phone and broker, and we're sending data to this messages topic. And what we want to do now is analyze the sentiment in the room using ML model. And for that, we would deploy a microservice subscribing for this topic and reading the messages into the memory. So let's do that. So here I'm going to add a new transformation. And although we have this particular example in library, so you don't have to actually code it, for the purpose of the demo and explanation, I'm going to do it from scratch. So there's a hello world transformation, which is a template for pub and sub transformation. I'm going to call this sentiment analysis, and I'm going to listen to messages and output it to sentiment. Cool. So I'm going to get the project, but before I go there, let me check if I have the stream. So here's the demo room. So this is each room would be represented by one stream in the topic. And here we have your messages. So that's amazing. Now, if I go back to my project here, here I basically get a Python project that give me this function template where I can react to all events and all parameter data that's coming from input. So first of all, I'm just gonna print messages you are sending me. So just to see if it's working. Yeah, so there are the messages you have all sent, and I'm getting those messages materialized in the line 10. So what we are using here is Quix SDK. It's a library that's making the reading and writing from and to topic a bit easier, and so we can concentrate on actual building. So now to get actual ML into the place, I will use our docs to just get some examples here. So there's a sentiment analysis, and there's like a GitHub link that you can use as well, and you can replicate it by yourself. And first of all, I'm going to import this pip library. So that's a already pre-configured library for sentiment analysis. The sentiment analysis here is not really that important. I just want to use some ML to give you an idea. It could be everything else. It could be fraud detection. It could be time series prediction, predictive maintenance. Doesn't really matter. The ML part here is the content of the model is not important. Is how we using the ML is what it's all about. So this will install this package, which is quite big. This is happening in a cloud, but some people just clone this and do it in their IDE.
Yes, just so people know, Thomas, what we are downloading here is Hugging Face, right? So for those who don't know about Hugging Face, it's AI community where you can find open source state-of-the-art databases or already trained models. And this is what we are bringing here. We are bringing their Transformers library, where we're going to use their pipeline object. This is an object that contains not only the ML model itself, but also the previous transformations that it needs to do on data. So we are going to be working with text, all the tokenization that needs to the data before the prediction phase. All that is happening there in that pipeline object.
By all means, this is not only for ML deployment. The content of the function could be just a mathematical transformation, data cleaning. It's not just for ML, but we're gonna start with this ML transformation now. So here I'm basically loading into memory, and then I'm gonna pass this artifact to my function here, and then in my function I'm good here import transformers pipeline, which is the type we can expect here. So cool. Now this function is created for each stream. So I can have some state and some variables in this function, and they will not get mixed if we're gonna have 5 different chat rooms happening at the same time. This is what the Quix SDK is doing for you. And it's managing the scope for each stream independently. Cool. So now we have our artifact. First, we're gonna print the actual message. And then here in the GitHub, we have a nice example how to use this particular ML model. Because it's not really that important, I would just copy paste this. What is important actually is the score. So let's print what the response for your messages is. So that's going to be here a score. So I'm going to run this and I'm going to ask you, for purpose of testing is, can you send me some more messages so we can see that this model is actually working when this gets downloaded into memory. Cool. So now I see that your message is coming and you see the number. So the number represents negativity or positivity of your message. So if it's +1, you guys were positive. If it's -1, you were negative. So this is working. That's quite cool. But we have just done the first part when we're reading from the broker to the memory. And now let's get it back to broker and send it to your application, to your phones. So let's stop this. And luckily, this is quite simple. So again, we're gonna use the Quix SDK, and we have here output stream prepare. Actually, before we do that, we also need to make the name of the stream this output end. That's what the front end is expecting. This is purely for the front end to work with this data. And here, this time I'm not gonna send event. I'm gonna send parameter. Parameter is a tabular data. Imagine a Panda data frame with a timestamp, different columns. This is what we're gonna send here. First, we're gonna send a timestamp of the row, so when the message was sent, and that's gonna be, and just pass that from the input. Then we have tags. Now, tags is something where we have your name and your phone number. We just again passed it to the output, and then we're gonna create a column called sentiment, and we're gonna pass the score. So that's the number. Then we're gonna pass the actual chat message. And lastly, it would be nice if we can track average sentiment per each room. So we measure if all people inside are in average positive or negative. So we're going to add another column in this table called average sentiment. And we're going to introduce two string variables. There's going to be sum and count. You might already see where I'm going. And here, each time I receive a message, I will just do a classical average calculation, and we are done. So now, if I'm gonna run this, cool. And if I go to this thing, to this application, and I say hi, it's green. If I say ugly, it's red. And you see on the right, the average sentiment is being measured, and it's bouncing over 0 because we have some positive and some negative messages. So that's pretty cool. And let's look at our slides, what we have achieved here. So we are sending messages to the cloud, to the broker. We are running in memory code where we getting the message into memory, calling ML artifact, and publishing the result of that call back to the output topic. And then we subscribing for that topic using the same WebSocket interface in our front-end application. But because this is not involving any database, there's no delay and there's no batching involved. The like 20 or 30 milliseconds from when you press the send, this is being analyzed, and then another 20, 30 milliseconds of travel back to your phone, and we are done. And although it's working nice, let's test the scalability a bit here, because you don't get that many messages to test it. So for that, I have prepared a connection to Twitter. So I'm gonna stop this sentiment analysis now. And because I'm happy with how it works, I'm gonna tag the version in a Git that I just completed as a V1. And I'm gonna deploy it into production. Cool. So that is now being built into Docker image and deployed to Kubernetes. In the meantime, let's connect to Twitter. So here we have some connectors to various data sources, and one of them is Twitter. And the idea here is that, and I have a slide here to show you, we're going to connect to the Twitter API, which is a really nice streaming interface. Only you have to be careful, because for free tokens that you have to get from Twitter, there's a limited amount of messages. And we're going to subscribe to Bitcoin tweets because they are just crazy. Lots of people talking about Bitcoin. And we're going to send those messages to the chat as it would be you sending messages from phone, just to kind of really create a massive discussion in the room. So if I go back, and I just need this token. Now, normally you get this token from Twitter dev portal, and you can create it by yourself. Here is basically a link for you to do it if you're gonna replicate this by yourself. And I already have a token here, so I'm gonna use it. And as you can see here, we're subscribing to BTC or lowercase BTC, and I'm gonna just run it. Looking good. It's connected and receiving tweet. And let's check it here. If I go to data and check the messages, oh la la, we're getting messages from Twitter. Now I'm gonna stop it for now, so we don't run out of our free quotas, because this is not everything. We are not getting these messages yet to our system. We need to convert the messages into our chat format. So for that, I'm just gonna here create a transformation, and this is gonna be a really simple one. So let's call this a Twitter transformation, Twitter to chat. And this is yet another example of pop and sap. So cool. We're gonna send all of the data to when this is ID is initialized. Yet. Cool. And we're gonna send all of that to a Bitcoin stream. And then here in Quicks function, I'm just gonna borrow this code because to save some time here. Every time we receive message from Twitter, I'm gonna convert it to our familiar event format that we're using in our front-end application. Cool. So before I run it, you can join me in a different room called Bitcoin. And if you scan this QR code again, you can just join me similarly as we did before. You can even send me some message here. Cool, amazing. So now if I go to this and press run, we getting Twitter messages into this chat room. Now, you might be asking, oh, hello, how I'm getting messages, even though I'm not running the connector anymore. But this is where Kafka really makes the whole pipeline reliable. You see, I have a downtime in my processing because I have created this processing after I actually get data. But Kafka will have a queue to make sure that if I have a downtime, data is not getting lost. But now I'm gonna go back here and I'm gonna start the Twitter again to just checking. This is basically now starting, running, cool. So if I now start the Twitter source again and go to this and there we are. And as you can see on the right, there is this massive measurement of sentiment. And as you see, the colors getting analyzed real time, and it's lots of messages being streamed from the Twitter. And let's check in our. So you see, this is using less than half of the core right now to analyze this amount of data. And that's because there's no database. It's happening in memory and using Kubernetes and Kafka together. So yeah, this is working. And now I'm gonna pass screen share to maybe slides, and let's let's talk about what we have done here. So messages are coming from phone, coming from Twitter, being sent to the same topic, being analyzed by sentiment analysis, and outputted back to the phone. And that's all happening in this workspace, and using total of half of a core. And now obviously we can save this data to database. I'm not saying that database is no longer needed. We actually need it for training, for example, ML models, but you put database to the side. So now if we go here in topics, you can persist these topics into database, or you can here go to destination and add a snowflake to persist your conversations. That's fine, but we are not building pipelines with the database in the middle to perform a sentiment analysis in the chat. So the last bit is our little QR code from marketing team. So if you want to try this at home and scan this QR code, and you get a double of credits for free, and it's plenty to build everything I did and have some fun with it. And you can connect it to your Twitter account and maybe subscribe to different stuff, and use Python ecosystem to build anything you want. I hope it was clear and not confusing. And if you have any questions, obviously we are here to answer them. I'm not sure what is the format of Q&A.
Yeah, I guess people can ask either on chat or unmute themselves.
Yeah. So let me check the chat in Zoom. Yeah.
So I have a question myself, so I'm just going to jump in. Sorry if everyone's typing. So this whole ecosystem that you built obviously is within the Twix platform, and the platform, are there any escape hatches that you built? Because you mentioned like databases and whatnot. So surely are those within your own system, or is that something you can connect to an external service for?
You mean databases of
yeah, imagine I want to put stuff in like a random RDS in Amazon or BigQuery or something. Are those connectors available?
Yeah, so here, and so this is like destination. So you have sources. Sources could be this front-end application. It could be some database, CDC, for example, or it could be a weather API. And then you have destinations. Well, we have here Redshift, Snowflake. You can send text messages to Twilio, send it to HiMQ. So, and if you are missing a connector that you would like to do, you can always inspire with other connectors and create your own. It's all open source, powered by GitHub. So this is the repository that basically is being used by this front end. So if you add a new service here and it's get approved in a PR, it will basically appear here as another tile. So I'm sure that there's lots of destinations, a lot of databases that are not here. So feel free to add your own. Yeah, does that answer the question?
Yeah, absolutely. Thank you. You got a couple of questions in the chat. Yeah.
Yes, I'm gonna go from top. So how much work went into writing the front end code that we didn't see? Well, it's super simple and naive front end code. And it's because it's using the APIs that we provide in Quix, so we didn't have to build it. I can actually go to that app here that is running in Quicks as well. And there are just two components and quick service. One component called lobby is where you put your name. And the quick service is where we connect to WebSocket gateways. And this is how we send the message. And then in the actual web chat, we just subscribe for what we want to listen. So you see here, I'm subscribing for chat messages from message topic, and then I'm subscribing to a sentiment, average sentiment in a sentiment topic, and that's it. And then we always have this HTML you saw where we printing the messages. It's not really anything complicated in the front end. Obviously, in a normal project, you would have something much more complex. So then we have another question. What is good use case for Quicks and what is bad use case for Quicks? Okay, so a bad use case, I will start with the bad use cases, is when you want to do a report at the end of the month. This is a typical batch example where you're going to read from the database and create a report.
Or even a model training, right, Thomas? A model
Yes.
training in many cases, you depend there on huge amounts of historic data in some cases. So Quicks and in general streaming wouldn't be the better application for the model training. However, talking about the model as well, for the model prediction in production, there you may be interested in your delay being as minimal as possible. You may be interested in reacting to the data as soon as it gets produced. So that would be a good use. I don't know which ones you were going to say, Thomas.
So, I mean, good use case is anything where you have a real-time data and streaming data. The funny thing is that streaming data is quite often things that you would not expect. And it's just that the technology in the past didn't allow on a small project to use streaming, but many use cases actually benefit from streaming that in the past were 100% batch. And anywhere where you want to scale. So Kafka and Kubernetes together are really scalable tech stack. You can go, and if I go here in the sentiment analysis and go inside and slide this replica to 10, I'm going to deploy this 10 times, and each replica, each instance would take 10% of the discussion, and I can do this pretty much forever. But database will hit the bottleneck. It is not, even though there are some databases today that are trying to shard the data and horizontally scale, it will hit the bottleneck. And also it's going to cost a lot of money. Databases have to use the disk, and therefore it's not that performant. So can you stream audio data or only strings? Of course you can. I'm gonna show you how you would do that. So if I go to, for example, this application, let's say that you would have some audio. You literally just add a new value here and call it binary. And here you pass a binary array. And you will then, when you're reading it, here, don't use string value, but binary value. So that's the change on reading, and this is change in writing. And that's it. So for example, video stream, audio, or LiDAR data in autonomous vehicles will come to that category. Could you touch on how would you deal with state between service restarts? Yeah. For example, your sentiment sum doesn't start from 0 always, but from last. Yeah. So here in library, we have do not commit. Here in library, we have examples of stateful processing. So here, for example, in memory view, this will persist state like the sum and count. I haven't used it to simplify this demo. The way how it works is that Kafka is checkpointing where the consumer left in the queue and what data had been processed. So think of it as a queue, and you are going with the cursor and you're processing data one by one. But Kafka is not persisting your position every message. It's doing it by default every 10 seconds, and you can actually configure that to longer or less. Now, what we do here is that every time the checkpoints happen, we persist that state into persistent volume in a Kubernetes, into disk. And if you restart after that, we will load that state into memory. And because we're going to start when the checkpoint happened, aka where we persisted last time, we will continue from the same state that we had at that point. If you would, this is called at least one processing. If you want to do one only processing, when you basically don't repeat the message being processed, you have to discard the messages that have been processed before the last restart as well. So here, if you would want to use stateful processing, use in-memory view example. And here you see that we are using setState method. So your count and sum would be in a state in some object that we would, every time checkpoint happen, persist to the disk. So yeah, and if you want to do exactly once processing, you would have to implement the discarding by yourself. Could you touch on how, yeah, that was the last message. So this seems that was the last question. Cool. So if you want to discuss something else and you just didn't, it comes to your mind after this meetup, you can chat with us using our Slack. So it's a stream processing Slack. Click on this button and you get into the Slack, and we can have a chat. There are channels we're discussing different things about streaming, or you can just send a message to me and have it directly. And yeah, I hope you enjoy the demo, and passing forward to Ray.
Yeah, thank you very much, Thomas. And yeah, that was great. Very impressive demo you got there. There are lots of stuff going on. I'm sure I'm still digesting how is getting to work all together like that, and the amount of stuff you could do with that. So yeah, unless anyone else has anything to kind of share, but we don't really have anything else from our side. I don't know if Theo has. I just noticed some links you posted there, so that should be helpful. Oh, there's a question.
Where do you want to go next with Quicks? Well, I think the biggest two things we have in our site is on our roadmap is first of all, have this view as a graph. We call it pipeline view. So you really see the pipeline in a graph view, and you understand the data lineage.
Basically
something similar
to the slides, right? Yeah, same that we were showing on the slide.
Yeah. The second thing, which is a bit more further, is we want to introduce more of a batch style development in a stream processing. By that I mean ability to control the flow of data. So you can start. It's like if you have a tap of water, you're closing and opening. So imagine the tap is your stream, and you just open it slightly to put a little in your code to see how that performs. And then if it doesn't perform, you just close it, and you are able to for example, do that in Jupyter Notebook and things like that. So that's our plans with the Quakes.